Hi, my name's Nick Howes. I'm the equipment consultant for Astronomy Now magazine, and I'm here to talk about solar telescopes. Solar telescopes really came about to the mass market for the amateur really in the mid-1970s with the introduction of the Daystar company. Delwood's Vic Winters from Daystar introduced a series of filters which became incredibly popular. Around about the late 90s, early part of the 2000s, Coronado introduced this product. This is the Coronado PST. This is probably one of the most popular solar telescopes on the market at the moment. Now, solar observing can be done in various different frequencies. It can be done in white light, and we'll be talking about that. It can be done in hydrogen alpha. It can also be done in a frequency called calcium K, K-line of calcium. Coronado PST, as I said, was probably the most popular and groundbreaking telescope of its time. What we have is a 40mm aperture telescope, very simple f10 type refracting telescope. Clear front view on the new models. On the earlier models, they integrated what's called an energy rejection filter into the front of that. Gold tube. This goes down to the heart of a hydrogen alpha telescope. It's called the ettalon. Now, what an ettalon is two very narrow separated pieces of glass, typically fused silica. These are separated by fractions of a millimetre, typically held together by nothing other than what's called optical contacting, where you have smaller pieces of glass, typically dotted around the edge of the circular ettalon, that hold the two ettalon plates together. What the ettalon does is take the light from the sun coming in through the front of the telescope. This is then converted into a parallel light beam, typically on the PST using a small lens at the front of the ettalon, passed through the ettalon, which then, using interference effects, effectively reduces all of the light down to a specific frequency of light, which is known as hydrogen alpha. This is at 656.28 nanometers. We'll be showing you a kind of image of the entire solar spectrum so you can kind of get an idea of what's happening. But you have on the sun spectral absorption and emission lines, and one of the key lines that's visible in the solar spectrum is that of hydrogen alpha. The hydrogen alpha light is then passed through the rear of the ettalon, and in the case of the PST, into a small prism which is located inside this black box. The prism then diverts the light up to the eyepiece, and here you can safely view the sun using any standard eyepiece or most popular webcams or cameras, and we'll be talking about imaging and camera use later as well. The really nice thing with the Coronado PST is that it has an integrated solar finder, and we'll be talking about how difficult it can be, even despite the sun being a large bright object in the sky, how difficult it can be to find the sun. But the integrated solar finder really makes this quite simple and easy to use. A very popular product, retails between £400 and £500 from a lot of popular astronomy stores in the UK and overseas. It's a well-made product. It's been around now for several years. It's one of the most popular ones on the market. Other ones that are available, you have a company called Lunt company, who are based in Tucson. Lunt came from the days of Coronado. Coronado were founded initially on the Isle of Man by two gentlemen by the name of David Lunt and Ken Huggett. They both went their separate ways several years ago. David Lunt went over to America, formed the Coronado Group, which is now a part of the Meade Corporation group, and produced products like this and a range of other products, the Solar Max series, ranging from 40mm all the way up to 90, and a few prototype, slightly larger telescopes, but the most popular range were between 40 and 90mm aperture. The larger the aperture, the more detail you can actually see on the surface of the sun. You can see more detail in things like prominences, in things like filaments in hydrogen alpha, and in active regions. So typically you'd be paying, as I said, between £400 and £500 for a 40mm instrument like the PST, anywhere up to £7,000 or £8,000 for a 90mm instrument like the Coronado Solar Max 90. So, Coronado set up in Tucson. Sadly, David Lunt passed away a few years ago, but his son Andy Lunt took over the company and set up the Lunt organisation. And now they are making a range of hydrogen alpha and calcium telescopes and filter systems. They started around about the £400 mark for a 35mm version, and go all the way up to, again, several £1,000s for a 150mm aperture instrument. The other part of the equation were this company. This is Solascope. Solascope remained in the Isle of Man under the leadership of Ken Huggett, and they started producing very high quality solar filters, hydrogen alpha solar filters. The difference between most of the solar filters on the market and things like the solar scope filters is that these are true Fabry-Perot ettalons. Now, talking before about the ettalon, the Fabry-Perot ettalon, this was in the late 1800s where two people called Charles Fabry and Alfred Perot basically devised the ettalon or interferometer system for this kind of observational work. Now, if you can imagine, in the late 1800s, they didn't have computers, they didn't have CNC machines or any of these specialist equipment for grinding down glass. They were literally grinding these plates, these very accurate, very flat plates of glass, down to 1/100th of the wavelength of light. It's quite an impressive achievement if you think of it in that context. So the Fabry-Perot ettalon, with Coronado and various other companies, what the ettalons are held together with is these pieces of glass, as I said, using optical contacting. But what they can do, or what they typically do, is they will have either a central spacer, it kind of keeps the glass nice and flat and straight, or they can use what's known as a Root 3 system on the Lunt telescopes, where again it's kind of keeping the glass more accurately in place. With the true Fabry-Perot ettalon, there's no obstruction in the centre, and all of the solar scope products are true Fabry-Perot ettalons. All of the spacing is around the edge of the glass, so you get a clear, whatever the aperture states it is, a clear transparent view directly through that. In terms of the design of a solar telescope, for hydrogen alpha use in particular, they typically follow a very similar pattern. At the front of the telescope, what you have is a piece of red glass. This is what's known as the energy rejection filter. This is a very high quality piece of glass. You can see it here on the Solar 50, and here I have an example of a Barda energy rejection filter, which I use with other telescopes. Very similar design in both instances. The red glass eliminates most of the harmful infrared and ultraviolet radiation which passes through the telescope, again allowing you to not safely observe the sun using this alone, because it's still a very intense light source, but it reduces the energy enough that the ettalon and the various other components inside the telescope can now manage the amount of energy coming through. So with the solar scope, this is a telescope in its own right. It has a lens system which works like a normal telescope obviously, but you can only use this telescope with the sun. That goes down to the rear, where you then have a secondary blocking filter. Now the ettalon itself, as I said, does eliminate most of the other frequencies of light apart from the 656.28 nanometer frequency of hydrogen alpha. But what you get with the interference patterns is side fringes or side bands. Now these side bands again will deteriorate the image and are not really ideal. So what you have is what's called a blocking filter or trim filter, an example of which I have in my hand here. This is a Coronado BF10 blocking filter. This is a secondary filter which again just reduces down those interference fringes so that what you're left with is a central peak at the hydrogen alpha 656.28 nanometer frequency. Behind that, you then place whatever you want. You can place your cameras. You can see here I've got my camera. This is a Luminara Skynix camera that I use for a lot of my solar imaging. Or you can place an eyepiece. Eyepieces and cameras tend to come to focus at different positions. With the solar scopes you may need to add adapters. With the Coronado PST you may need to add adapters as well, or Barlow lenses to get the camera to come into focus accurately. But most eyepieces work with most of these telescopes quite successfully.